we are looking at a typical podzolic soil that we can find it in this region. This soil can be classified as humopheric podzol, and it's characterized by its very well-developed BF horizon, which can be recognized by this very deep red color. These soils are, as I said, typical for this region. They are formed on glacial till type of parent material or morainal type of parent material, and they inherited their relatively moderate to coarse texture from these coarse textured types of parent material. If we would like to identify horizons in this soil, we would start from the top, where we have a forest humus form or litter layer. And if we take a chunk of that forest floor, we would see that, and examine it closely, we would see that level of decomposition in this forest floor is not well advanced, because we can recognize the individual bits and pieces of original plant debris, which indicates low level of decomposition and which then places this type of forest floor into the moor group. Under the forest floor in this soil, we have a very thin AH horizon. That's a mineral horizon with enrichment of organic material. It's only 3 up to 5 centimeters in thickness. And in this particular soil, we do not observe any AE horizon. AE horizon is not typically present in podzols in this part of the Vancouver Island. Underneath AH, we have a very prominent or thick BF horizon, dominated by accumulation of iron and aluminum oxides, which gives this horizon this rich red color. Iron oxides are characterized by this red color, and by saying prominent, I'm saying that the thickness of this BF horizon is quite large. It's about 1/2 meter in thickness, so that means that it had time to very nicely develop. This reddish color then, if we go further down into the depth, turns into the orangey yellow color, which is again a typical feature of these podzolic soils at this part of the Vancouver Island, which would be on the top of our BC transitional horizon from a B to a C horizon. We opened this soil profile to the very top of C horizon, which is basal till, and it's very dense. It's very hard to dig through, especially if you only have a shovel. You might need a pick to break this very compacted, very dense C horizon. This C horizon, and I'm banging on it, is called a basal till, and it's characterized by its hardness. In pedology, we call this layer a duric horizon, indicating again its very hard nature. The consequence of having such an impervious, hard, dense layer in a soil profile relatively close to the soil surface is that roots that are growing of the plants that are growing on this site will have difficulties penetrating through this, and they usually cannot. So this would be a root restrictive layer for them to grow. Also, water that moves through the soil profile will start accumulating, especially during the wettest part of the year, at the top of duric horizon, with this dense layer that we are just seeing the top of here. We recognize the accumulation of water at the top of this horizon by certain features that are present on this horizon, such as presence of mottles or yellowy orangey spots that indicate oxidizing conditions, and the rest of this duric horizon has dull grayish color which indicates reducing conditions. So during the wettest part of the year, this zone on the top of this layer will be lacking oxygen because it will be completely filled or saturated with water, creating reducing conditions. When water eventually, during drier part of the year, manages to find some pathways and go through this dense layer, then oxygen goes in. Iron oxide changes its state to oxidized state, and it changes its color to orangey reddish color, sometimes in some soils yellowish color. Another thing that we can see on these on the top of this dense layer are dead roots that accumulated here over the years. And it's very common to see dark purple, almost black stains at the top of this layer, and I have a piece of it here. These are roots that reached the dense layer. They couldn't go further into it. They died, and then their debris started decomposing, forming these purple, dark purple stains on the top of this layer. In summary, soil like Podzol that we just observed are characterized by several important features. First of all, because they have heavy accumulation of iron and aluminum oxides, they're very acidic. And that also means that they have limited amount of base-forming cations, calcium, magnesium, potassium, and sodium, which are all important nutrients for all plant species. Their strong acidity also impacts the type of soil organisms in this soil, because fungi would be more tolerant of surviving in such acidic environment than bacteria. And last but not least, these soils have this dense duric layer at about, in this case, 60 or 70 centimeters, which limits the volume that's available for roots of higher plants that grow here. And also that layer is limiting for the water that moves through these soils and will accumulate on the top of that layer, especially during the wettest part of the season.